Looking at section 3.4, part 2, I'm going to start by using the definition of a logarithm to solve logarithmic equations. So step number 1 says to express the equation in the form log b of m is equal to c. Use the definition of a logarithm to rewrite the equation in exponential form, meaning we're taking whatever that base is, raising it to the power c, and setting it equal to m. So that's where we get this b to the c is equal to m. It says solve for the variable, and then check proposed solutions in the original equation. Include in the solution set only values for which m is greater than 0. When you're taking a logarithmic function, this value m has to be positive. If m is not positive, you cannot take the logarithm of it. So for example, it tells us to solve, we have a log base 2 of x minus 4 is equal to 3. So we're going to take and rewrite that in exponential form. That means we're taking 2 to the third power is equal to x minus 4. 2 to the third power is equal to x minus 4. Well, 2 to the third power is 2, 4, 8. So we'd have 8 is equal to x minus 4. And we can solve easily to get x all by itself. X is equal to 12. So our solution set is 12. If we were to solve a 4 ln of 3x is equal to 8, our goal is to get x all by itself, which means we need to get rid of that 4 first. We get rid of that 4 by dividing by 4. So ln of 3x is going to equal 2. Well, ln has that base of e, which means e to the second power is going to equal 3x. E to the second power is going to equal 3x. And then I want to solve to get x all by itself. I'm going to divide by 3, divide by 3. So x is equal to e squared divided by 3. So we get e squared divided by 3. Could we get a numerical value for that? Sure. E is just a single number, right? Just like pi is an irrational number, e is an irrational number. We could get a really ugly decimal, but simplest form is just e to the second power divided by 3. Let's try another. This one says to solve the logarithmic equation, we have a log of x plus log of x minus 3 is equal to 1. Now this is where we get back into condensing our logarithmic equations. So since we have a plus, that plus tells us that we are going to end up multiplying. So we're going to rewrite this as a log of, technically it's going to be an x times an x minus 3 is equal to 1. Now I have a logarithmic function, it's just a base 10 in this case, which means we're going to have 10 to the first power is equal to our expression. So 10 to the first power is going to equal x times an x minus 3. Well, we have to do a little bit of algebra. We need to distribute out that x. So that means we have 10 is equal to x squared minus a 3x. We want to get everything to one side of the equal sign so we can simplify this. 0 is equal to an x squared minus a 3x minus a 10. And now I'm going to look to see, can I factor it? If I can factor it, that makes life a lot easier. If I can't factor it, I might need to do like the quadratic formula or complete the square. But in this case, this is actually factorable. So we end up with x times x, multiply to make 10, and then subtract to make our 3. We're going to have a 5 and a 2. Since that's a minus 3, it's going to be a minus 5 and a positive 2. That means when we solve this down, if x minus 5 is equal to 0 and x plus 2 is equal to 0, x equals positive 5, x equals negative 2. Now I have two solutions, but I need to make sure that I don't end up taking the logarithm of a negative value. So I need to go back and check them. So if I have a 5 and a 2, let's check 5 and let's check negative 2 since x was equal to 5 and x was equal to negative 2. So let's plug it in. If I were to take a log of 5 plus log of 5 take away 3, that has to equal 1. So I have a log 5 plus a log 5 minus 3 would be 2. We want to know, is that going to equal 1? I have an addition, which means I'm going to have a multiplication. So log of 5 times 2 gives us a log of 10 is equal to 1. Well, 10 to the first power is 10, so 1 is equal to 1. That's going to work out okay. That's true. Let's double check that negative 2. So if I take a log of negative 2 and I add log of a negative 2 minus 3, is that equal to 1? So I have a log of negative 2 plus a log of, we have a negative 5. And then if I have an addition, that means I have a multiplication. However, right now I have a logarithm of a negative value in both of these cases. Can I take the log of a negative value? I cannot. So that is not going to be a solution because that m value had to be positive. It's kind of like taking anything to a power. If I took a number, they said like that, what was it? B to the C was equal to M, B to the C was equal to M. If I take and do any sort of power, anything to a power, I'm never going to end up negative, right? No matter what I take to a power, it's never going to end up negative. That's why our logarithm cannot be a log of a negative value. You're going to blow up your calculator. It's going to tell you have an error. That means negative 2 is not going to be a solution. So negative 2 does not check out. That means our only solution is going to end up being that positive 5. So using the one-to-one property of logarithms to solve logarithmic equations, it says, express the equation in the form log b of m is equal to log b of n. This form involves a single logarithm whose coefficient is 1 on each side of the equation. Use the one-to-one property to rewrite the equation without logarithms. So it says if log b of m is equal to log b of n, then m is going to equal n. Think about it. If I have a log b and a log b, that means m and n are going to equal each other. So then it says to solve for the variable, and then again we had to check the proposed solutions in the original equation and include the solution set only, or include in the solution set only values for which m and n are both positive, right? We cannot take the log of a negative number. Let's see what we got. I have the natural log, or ln, of x minus 3 is equal to ln of 7x minus 3 minus ln of x plus 1. So let's simplify down that right-hand side. So our left-hand side is going to stay as an ln of an x minus 3, but our ln of 7x minus 23 minus the ln of x plus 1, that subtraction tells us that we're turning it into a division. So I'm going to have the ln of, we have a 7x minus 23 divided by an x plus 1. Now that I have the ln of each side, right, they both have the same base of e, I can state that x minus 3 is equal to 7x minus 23 divided by x plus 1. And now our goal is to solve to get x by itself. So we have a bit of algebra to do. Since I have that division over on that right-hand side, I'm going to move that x plus 1 to the other side by multiplying, which means I need to FOIL. So that means we're going to have an x squared, a minus 3x, and a plus 1x is going to give us a minus 2x and minus 3. That's equal to a 7x minus 23. Now solving to figure out what x is, let's get everything to one side of the equal sign and hope that we can factor it. So I need to subtract that 7x over. I need to add the 23 over. Cancels out. We have an x squared, we have a minus 9x, a minus 3 and a plus 23 is going to give us a plus 20. And that's equal to 0. Multiply to make 20 and add to make 9. 4 and 5. So we're going to have an x with a 4 and an x with a 5. Same signs, they have to be minus signs. So x minus 4 and x minus 5, which means x is equal to 4 or x is equal to 5. So we have two possible solutions. We have a 4 or we have a 5, and we need to check them. So if I check those two, I want to check to see, does 4 work? Does 5 work? So if we go about plugging that in, ln of 4 minus 3, which is an ln of 1, equals 7 times, whoops, I need my ln of 7 multiplied with 4, take away 23, minus ln of 4 plus 1. I got a little too big on that, sorry. So let's see, 7 times 4, that gives us 28. 28, take away 3, that gives us ln of 5. Minus, we have an ln of 4 plus 1 is 5. Now, if we have our natural logs and we have a subtraction, that means we have a division. So 5 divided by 5, that's going to give us an ln of 1, which we had an ln of 1. So what happens? That looks good. They are equal to each other. Let's try the other one. If I have an ln of, we have 5, take away 3, so we have an ln of 2. ln of 7 times 5 minus 23 minus ln of 5 plus 1. 7 times 5, 35. Take away the 23, that gives us an ln of 12. Minus ln of 6. If I have ln and ln, we have ln of 12 divided by 6, which gives us an ln of 2, which is equal to an ln of 2, and that also looks good. There's no limitations with either the 4 or the 5. They both check out okay. So we have two solutions in this case. We have 4 and we have 5. Says, application, how long to the nearest tenth of a year will it take $1,000 to grow to $3,600 at 8% annual interest compounded quarterly? So the one thing they don't tell us numerically is quarterly, but at this point you hopefully know that n is equal to 4 if it's quarterly. Our 3,600 is going to be our A. We want it to grow to that amount. Our initial amount of money, our principal that we're putting in is 1,000. And obviously that 8% is going to be our rate, but we need that as our decimal, 0.08. So let's fill this in. Our A value of 3,600 is equal to our principal of 1,000 times 1 plus 0.08 R divided by the N, which is 4. And that's going to be raised to the N times T. So that's a 4 times... our time is our unknown. T is what we're trying to solve for, so that's going to be a 4t up there. Now, let's start simplifying this down. We need to eventually get t all by itself. So let's go ahead and take care of getting rid of that 1,000 in the front. So if we divide by the 1,000, divide by 1,000, we're going to have a 3.6 is equal to, well, let's simplify the inside of those parentheses. 0.08 divided by 4 is a 0.02. So that's going to give us a 1.02 raised to the 4t. Now from here, in order for me to start using those logarithmic properties, we need to take the natural log of each side. So that means I'm going to take the ln of this side and the ln of that side, if you're okay with me squeezing it in. So now, if I have this ln of 3.6 is equal to ln of 1.02 to the 4t, now I can take my exponent and I can go and drop that down in front. So ln of 3.6 is going to equal 4t times the ln of 1.02. Now we can start getting t all by itself. T is being multiplied with 4, so I need to divide by 4. It's also being multiplied by ln 1.02, so I need to divide by that. Whatever I do to the one side, we're going to do to the other. 4 ln 1.02. Now, plugging it into the calculator, be careful. You'd want to make sure you throw some of those in parentheses down there, right? So if I were to take my ln of 3.6, divide it by, in parentheses, 4 ln 1.02, the calculator is going to tell you approximately 16.2. So it's going to be about 16.2 years for that $1,000 to grow to $3,600. And one last example. In the last example, we talked about the height of boys. This one's going to talk about the height of girls. So it says the percentage of adult height attained by a girl who is x years old can be modeled by that function f of x is equal to 62 plus 35 log of x minus 4, where x represents the girl's age from 5 to 15, and f of x represents the percentage of her adult height. At what age has a girl attained 97% of her adult height? So we have an equation. We're trying to figure out when will they be 90% of their adult height. That means that our f of x is going to be 97. So 97 is going to equal 62 plus 35 log of x minus 4. Our goal is to get x all by itself. So if I want x by itself, first thing that has to go, subtract that 62. So if I subtract 62, that's going to leave us with 35 is equal to 35 log of x minus 4. Well, that's an easy division. If I divide by 35 and I divide by 35, we end up with a 1 is equal to log of x minus 4. Well, log is a base 10, which means 10 to the first power is going to equal x minus 4. And if I solve to get x all by itself, I'm going to add 4. I'm going to add 4. And our x is going to equal 10 plus 4 is 14. So at approximately age 14, a girl has attained 97% of her adult height.